Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and Question 5. Study the intensity distribution diagram for a diffraction pattern from a single slit of width A. The positions of two minima on each side of the central maxima are labeled and they are not drawn to scale. We need to answer the three parts. Let's take part A. So it is saying determine the ratio of width of central bright maximum to the width of the secondary maxima above it. So this is the width of the central bright maximum, and this one is the width of the secondary maxima above the central maxima. So we need to take the ratio of this. So width of central maxima, it can be obtained as y1 minus y1 dash. So I'm calling it as y1 dash. So the width of central maxima is nothing but it is the distance between the two central minima on either side of the central maxima. So let me call it as w1, and it is equal to lambda by a minus lambda by a, that will be equal to 2 lambda divided by a. So this is my equation number 1. Now for the width of second central maxima above the second maxima above the central maximum. So that is W2, and we can see that it will be equal to Y2 minus Y1. So that will be 2 lambda divided by A minus lambda by A, and it will be equal to lambda by A. That is W2. Now we can take the ratio of these two, because that has been asked in the question. Ratio of width of central bright maximum to the width of the secondary maxima above it. So W2 ratio W1, it will be equal to 2 lambda by A divided by lambda by A. And when we solve it out, it will be equal to 2 ratio 1. So the width of the central bright maxima to the width of the secondary maxima above it, it is 2 ratio 1. Now let's take part B. What is the sine of an angle at which the secondary maxima is produced above the central maximum? So we need to find the sine theta. And we know that when we have derived the formula for this single slit experiment, we have obtained that sine theta, it is equal to n plus half lambda by a. So this is the value of sine theta. And we need to find it for n is equal to, and this is for maxima. If it would have been for minima, we need to just write n lambda. So putting n is equal to 2, we can write sine theta is equal to 2 plus half multiplied by lambda by a, and that will be equal to 5 upon 2 lambda by a. That is the value of sine theta. So this is the sine of angle at which the secondary maximum is produced above the central maximum. Take part C as well. If the slit width is made half as wide, what will be the effect on the width of its central bright fringe? So what we are doing, we are reducing this A to A by 2. So earlier the slit width was A, now we have reduced it to A by 2. And we all know that sine theta, it is equal to plus minus lambda by A. This implies this thing that theta is inversely proportional to A. So when A is reduced, then theta will increase as they are inversely proportional. And when theta is increased, the width of central maxima will also increase. So if we reduce the distance between the slits, then the width of central maxima will increase. And that's the answer for part C. Keep learning, keep practicing, keep excelling.